So today is just a short recording of presenting lattice multiplication. Starting out this way, just showing the different components that I am using for this presentation. I have both screen sharing on, so I can see my computer as well as my other laptop that I have over here. As you can see, I am sharing the screen. I do have at least one other person in the room. I'm presenting. Then we have John Smith, who's also me, obviously, as you can tell by the camera. And then we also have the text chat open. So, as you can see, it is working, and John Smith is saying that he is here. So I am here. In both aspects of the word, makes it more interesting. So we have that going on. So I'm also using PowerPoint for the presentation part of this as well. So there is both. Unfortunately, when the PowerPoint presentation is going on one computer, it does seem to actually block it on the screen itself. So that, unfortunately, kind of blocks out where I'm able to see them, but they're still able to see me either way. So with that being said, I'll move on to my presentation. So today I'm going to go over how to do lattice multiplication. And what is lattice multiplication, you ask? Lattice multiplication is a different way of doing your times tables. They're larger, obviously. If it's single numbers, it's not going to work as well. But it's basically putting the multiplication equation into a box and dividing it into a grid of basically lattice. So when we move on from here, we're going to show you how to use lattice multiplication. So we're going to do 42 times 35. So to begin, you draw a 2 by 2 box. You're going to put 42 on the top. 35 is going to go on the right side of that box, just like it shows here in the picture. After that, you're going to do diagonal lines. You're going to go from right to left inside of the boxes. And you're also going to extend a little bit past the bottom two to keep your numbers separated for each of your columns, we can call them. So we're going to start with the first line. We're going to multiply each number together. 4 times 3. The answer is 12, so you're going to put this in the first box. So you have 4 times 3 is 12. 1 on top, 2 on the bottom. The same thing with 2 times 3, which is going to give you 6. So you're going to do 0, 6. 0 on top, 6 on the bottom. Moving on to the next line, you got 4 times 5. That's 20. First box on the left of the bottom row, 2 on top, 0 on the bottom. Now we're going to multiply the last box here, which is 2 times 5. That's going to be 10, so we're going to put that into the final box that's open, 1 on top, 0 on the bottom. This is cool. This is actually very cool, John. So multiplying there, you're finished with the multiplication part of it. Now we move on to the addition. So starting from the bottom right, you're going to add each of the diagonal lines together like so. 0 plus nothing else is 0. And then you have 6 plus 1 plus 0 equals 7. Then we have 0 plus 2 equals 4. Then we have 1 plus nothing equals 1. So the total in the answer for this equation is going to be 1,470. and that will be the actual solution to our problem. It's really actually quite simple. So things to remember when you are actually using this. You need to make sure that you draw the boxes, the diagonal lines, add only the diagonal lines from right to left. There's only one way that they really actually go. You're going to read your answer from left to right. And it's also just simplifying the multiplication equation into smaller single-digit multiplication equations itself. And just as a fun tip, everyone always remember that guy who always bought all the watermelons in our math classes. Why? Never understood it. He's been found. He's actually here. It is pretty funny, and I can't believe they found him either myself, but you are correct. They found him. I don't know who, but I wish I knew who. That's funny. I wish I knew who too. So there's a very simple way to do longer multiplication problems. It's as simple as just breaking the problem down into smaller multiplication problems and working them out in single digits instead of trying to do doubles and triples. And then it's simple addition.